them a break. So this session is called Angular plus Drupal, a compelling combo. That was an early draft of the talk title, but we also gave it the title Building an Ecosystem for Tomorrow, because this talk is really all about bringing Angular and Drupal together in various different ways, but also thinking about how do we combine these ecosystems, because I think, as it's been said earlier today, a huge part of the success of Drupal, and I'd say a huge part of the success of Angular, is the ecosystem and the community that forms around these technologies that really makes them valuable. And so really trying to think about how do we evolve these ecosystems collaboratively. So I'll do brief introductions. My name is Stephen Fluin. I'm a developer advocate on the Angular team at Google. So my role at Google really has two parts. First, my job is to help developers and businesses be successful with Angular. And then second, it's to understand what it's like to build software in the real world so we can reflect those needs onto the Angular team. Before joining Google, I spent about 15 years doing enterprise consulting, where I was helping companies figure out, okay, we have a problem, we need to solve that problem with software and with technology. How do we navigate this crazy landscape of tools, choices, opportunities? So that's really kind of my sweet spot, is thinking about how do we apply technology to solve business problems.
And I'm Matt Davis. You've all already heard my introduction, but for the video's sake, I'm the Director of Emerging Technology at MediaCurrent. And I've been playing with Angular now for a couple years. And I have, as you see there, I'm a big fan of TypeScript.
All right, so this presentation is really going to have three parts. First, we're going to talk a little bit about Angular and make sure we all have the same background. I'm going to assume that you are all web experts, so I'm not going to go into any of the basics about construction, or I'll assume that you can kind of figure out a lot of that on your own. Then we'll get into the Contenta project and Contenta Angular in particular. We'll talk about how it was built, what it does, how it does it, those sorts of things. And then I want to wax a little bit about how we are heading and trying to evolve these things in terms of making Drupal plus Angular an even better combination. And so, if anyone saw me, has anyone seen me in your DrupalCon New Orleans? Okay, a few of you. I apologize. That was actually my first week on the team, so I know Angular much, much better now. So we're starting off with Angular for web experts. So for those of you who don't know, Angular is a platform that makes it easy to build applications with the web. And so as it was said earlier, this is kind of what everyone's trying to do, but we use kind of three of these terms very intentionally. So the first term is platform, because Angular is really trying to own the end-to-end developer experience of all the things that have to come up as you're building an application, as you're thinking about architecting an application, and as you're bringing that application to production out in the world. Second, building applications. So as we move away from kind of these static server-driven websites into much more dynamic, engaging things, a lot of people say, oh, well, what's a website, what's an application? I don't really differentiate them, because the moment that you have a website, you want to start adding features, right? You want to start adding engagement to your users, and at that moment it kind of becomes an application. And the last piece is with the web. So one of the big things that's happened on the Angular team and with the Angular project is that we're really focused on leveraging the web as it is today, the modern web as we call it. If you look back to AngularJS, it was a much more complicated framework because the web wasn't as good as it is today. Whereas Angular is actually much simpler now because we're relying on things like ES 2015 modules, classes, and all these kind of best practices that most of the industry has started to adopt at this point. So as the Angular team, we value kind of three things. So we value apps that users love to use. So this is all about user experience. Does it load up fast? Does it give me great experiences that engage me? Apps that developers love to build. So how do we make the developer experience of architecting, trying to solve all these challenges as easy as possible? And lastly, a community where everyone feels welcome, because as we started off, this is all about ecosystems and community, because the more people that we can empower with these tools, not only to build applications, but also to build other tools and to build other libraries and other frameworks, the better we feel about that, and the more healthy the ecosystem is going to be overall. So for those of you that don't know, Angular really has a few kind of core tenets, or things that you're going to recognize off the bat. The first thing that you're going to see is we have dependency injection built in. Then you'll see something that we call declarative templates. So this is using HTML in order to explicitly state what you want the application to look like at any given moment. And we're very opinionated about using TypeScript. And so all of the Angular examples that you see, most of the Angular applications that are built today are using TypeScript under the hood. So this is a component in Angular. So at the top we have an @component decorator, which just says, here's the metadata for our class or our component that's going to be rendered on the screen. I'm pointing off to an HTML file that has all of my declarative content. And then I'm using an ES 2015 class here, so I'm saying export my component. And then within the constructor of that class, we're using TypeScript in order to do our dependency injection. So if you think back to AngularJS, which a lot of you are familiar with, we had basically hung everything as globals on the global state, which is not a great way of doing things. Because we're leveraging TypeScript now, we can actually ask for something by its symbol name and give you exactly the thing that you want in the way that you want it, which is a much cleaner way to build applications unambiguously, because at the top of this file, you would have an import and you would actually say, here's the HTTP class that I want to be using. On the declarative template side of things, this should look relatively familiar if you've done any sort of HTML templating before. So at the top, we've got a div. We're actually using what we call an ngIf statement here that's just checking for asynchronous data. So I've got this data variable that's coming in asynchronously by an observable. I'm piping that through async and then saving it locally. And then I'm able to render out data from that object. And then I'm able to iterate over the children using ng4, and then getting out the text of each of those children. So this is relatively simple. This is all actually valid HTML, surprisingly to me, at least. I didn't know stars and things like that were valid, but they are. And so this is really our idea of how do we make this as easy as possible while still limiting it so that it's a strict subset that makes sense and is manageable from a static analysis standpoint and a compilation standpoint. All right, so I think it's also helpful to think a little bit about how Angular is organized as a project, because there's a lot of different pieces now as the platform continues to evolve and grow. So at the base layer, we have the Angular repo on GitHub, as we call it. So Angular org, Angular project. And this actually has a bunch of different modules that we ship separately on NPM. So you have everything from our compiler, which you're going to use at build time. We've got something called Platform Browser, which takes a generic Angular application, which is not DOM dependent, and gives it all the knowledge of what needs to happen in a browser in order to render that out to HTML. We've got Platform Server that allows you to do server-side rendering. So maybe I want to get out an HTML string of my application instead of something that's going to be run inside a browser. We've got an animations library, and we have a lot more. So internationalization, a mobile toolkit, forms. So these are all kind of sub-projects within the Angular repo. And each of them has owners. They're all kind of considered components of that repo. Then on top of it, we have kind of bigger, more dedicated projects. And so each of these projects has kind of a team around them. So on the left there, we've got Angular Material, which is our way of taking the material design philosophy from Google and making it available to you as ready-to-go components. Then we also have a CLI, which we're really spending a lot of time making awesome as we can here. Then on top of that, we actually have a lot of other people working on Angular at Google that are contributing back in various ways. So within Google, we have tens of thousands of engineers. And so developer productivity is actually a really big focus for us. And so we actually sit next to the TypeScript team within Google, saying how do we use these tools to better scale out code and things like that. We also have things like Google Cloud Platform, lots of other teams. I think there's over 300 applications within Google that are built on top of Angular right now. And we invite all of those teams, just like we do in the open source world, to contribute back to Angular, solving for new use cases and things like that. Our CLI workflow really, as I said, tries to take end-to-end the developer concerns that they have. So everything from scaffolding out a new project when you don't know anything, you don't know what best practices there should be, what to do, generating new code, making things faster, serving it in a kind of live reload process, testing, building, deploying, shipping your code, all these sorts of things. We have CLI commands for those. Lots and lots of companies use Angular. I think there's more than 100 or 200 applications launched in production every day. It was a really exciting number to us. Most of them are also using the latest version, which is exciting for us because a lot of people are concerned about the version number of Angular. But we really do want it to just be, it's just Angular. You just use the latest version and you're not going to have concerns or problems staying up to date. We talked to a lot of those companies about why they choose Angular. And there's really comes down to 5 reasons overall. So we're opinionated, so we're going to make sure that a lot of these things, these various tools work together out of the box. We're trustworthy, so we have a very committed, very public release schedule. So you know when the next major is going to be, you know when the next minor is going to be, and you know how quickly we're going to evolve the framework, and it's all done open source. It's familiar. A lot of people are coming from AngularJS, and we have all the same kind of philosophies and ideas in Angular. But we also have a lot of developers coming from PHP, Java, .NET, where you've got these more rigorous kind of back-end technologies that we're instantiating those same sorts of ideas now on the application side, client side. It's also familiar to a lot of Drupal developers because we have some of these same concepts like dependency injection. Angular, we consider it scaled. It's in use at Google, lots and lots of users, but also scaled within a team. So if you have various different perspectives, so you've got designers that are working on HTML, you've got architects that are working on more architecture module levels, and then developers working on more component level things. We built Angular to think about all those different perspectives so that those people can collaborate together. And then lastly, we've got an ecosystem that we care a lot about and we spend a lot of time helping. So to kind of bridge the gap, we have a compiler, and in that compiler we're able to do a lot of different things. So we actually take all of your declarative HTML, and we, ahead of time, so at build time, when you're writing your code, we're going to turn all of that into JavaScript, VM-optimized JavaScript. And because we have TypeScript, we can do static analysis, and we can try and do things a little bit better. So we can understand what's going on deeply within your application, and then make optimizations for whatever target you're going for. And so for us, the combination of this ahead-of-time compiler, static analysis, and our focus on developer concerns means that in the long term, we feel like we can do a lot to make Drupal developers successful, no matter what you're trying to do with Angular. So with that, we've been working on a project, and I'll turn it over to Matt.
Awesome. Thank you, Stephen. So as Stephen mentioned, we've been collaborating on a new Angular project the last couple of months, and we're really excited to talk about it today and show you guys a little demo. The project is called Contenta Angular, and we have a whole separate session about Contenta. I know Ed mentioned it as well. I don't want to steal their thunder, and I'll let them explain in more detail what Contenta is. But the basic idea is that we're really trying to lower the barriers to entry to getting involved with Decoupled Drupal. And we're building, so we have a back end, and then we have various front end rendering consumers built on top of it. So Contenta Angular is the Angular consumer that's built on top of the base Contenta distribution. And the goal here is really to showcase what a best practice fully decoupled Angular application that's built on Drupal should look like. And I need to give special shout outs to the rest of the team that's contributed to this project, Sam Mortensen, and you say it, I'm going to butcher the name. Joao Garim, who have both done a lot of the work underneath the hood to make this project a success. And I would encourage everybody with the phone, which is everybody probably, to pull it out and pull up the actual site and follow along, and you'll see why I want you to do this in a few minutes.
What year did we stop asking, or what year do we need to stop asking?
It's been a while. Yeah, it's been a while.
We've got the URL here, Kangular.
Kangular, yeah. Contenta Angular. And the GitHub repos down there as well, because the entire project obviously has been open source since day one. So these are just, I'm going to go through some of the features that we have working underneath the hood of Contenta Angular before we do an actual live demo. So as Stephen mentioned, there's a really nice CLI baked into Angular. It's actually originally forked from the Ember CLI, and that was some of the original inspiration for it. And it's gone on its own some, but it's very powerful. And what we really think is important about it is that it serves that key piece of helping to lower barriers to entry. Because like Drupal, there's a lot to learn inside of Angular. It is a very big platform, and the CLI really lets you get in quickly and start playing around and producing things really, really quickly. So this is just an example of what it would look like to build a new project and then generate a component and serve it out. With just a few commands, you can have a running Angular application. And then another thing that we've done is we've actually abstracted out the entire services layer. So there are actually two projects, and Samuel Mortensen was the one that did a lot of this work. So there are actually two Contenta projects built on top of Contenta Angular service. The main Contenta Angular that I'll be talking about, but also a separate Ionic project. So this was kind of an experiment in how we can reuse some of the same tooling across different projects. And the hope in the long run is that all of our data models and our HTTP service will be abstracted enough that it could work not just for Contenta, but for any kind of decoupled Angular project that you might build. And so this is an example of what one of the data models looks like. So you'll see Content Angular, it's kind of a recipe site. And we have some custom decorators in here. I think Stephen alluded to decorators providing special metadata. But what you see here is that they're very simple to define these data models. And because Contenta is all built on JSON API, our services layer actually gives us a lot of the goodies of JSON API for free, things like relationships between different content types and things like that. And then, as I said, the HTTP layer is abstracted as well. So Angular has its own HTTP built in, and we've actually abstracted that out to work really well with JSON API as well. And state management, another important part of building out a large application, is figuring out how do you handle all the different types of state that an application may have to deal with. So we heavily leverage NGRX4, and the easiest way to see this on the site, which I'll demo here in a few, is to play around with the filters. So what happens when you change a filter is it actually changes a route, which then kicks off an action, and then very much like the Redux functional pattern, we have functional reducers that then decide how to affect state. And one interesting thing about the way effects work with NGRX4, so we do optimistic state changes. So for example, if you're making a state change that has to affect a post back to an API call, we assume that that post is going to work and go ahead and update the state locally, and then a side effect is kicked off that actually performs that API call. If it were to fail, it can then kick off another reducer that reverts that change. So we can update state optimistically, but also have fail-safes in place in case things go awry. That way you don't end up with weird inconsistencies in your state of your application versus the actual backend. Another cool feature that we have baked in is Serverpush. So the demo host that we're going to be showing you the site on is Firebase, which runs on HTTP 2 by default. And Serverpush is a newish. How many people here are familiar with Serverpush? I think there's been a lot of people talking about it, but I have never used a site that actually used Serverpush before. What it allows you to do is, instead of when you send a request, then having to parse through your HTML and pick out resources and then load those resources, you can actually push with the initial request static resources that you know your user is going to need. So this is all about getting that first pain down and giving the end consumer stuff that we know in advance that they're going to need. And another thing that we're really excited about with the Content Angular project is how much of the progressive web app feature set we've actually baked in. So a progressive web app is the idea that instead of having to download an app from the App Store, we can actually make normal websites behave more like applications. And that means they should run on any size, on any speed of network. They should be installable as web applications, and they should also leverage service workers. So with a small manifest.json file, this is what actually provides some of the basic progressive web app functionality here. So we have icons, and we have a whole bunch of them. Actually, I've truncated this. But what that does is when you install this as a web app, it will provide the icon for your home screen. And then we give some theming information as well, so that when you load this on your phone, you'll actually get a special splash screen that is kind of the mobile side splash. And if those of you who have pulled the site up, if you load that again after not using it for a few minutes, you should get prompted to install it as a web app if you want to as well. And that's all generated by just having a small manifest file. Service workers. This is something that we're super excited about. How many people here have played with service workers before? A lot of you. Awesome. So this is what really gives a lot of the core functionality of the progressive web app, where we can do all kinds of cool things related to caching our assets as you navigate around the page, and then ultimately serve the entire site offline capable. Once you've browsed around a little bit, you can turn off the internet and continue to browse the site. And in Angular, there is a baked-in service worker integration as well. So for any basic Angular application, it's literally just a few commands to have basic service workers running on your application. So with just these 3 commands, you can test that out on an existing Angular application. So overall, how do we feel like the Content to Angular project is going? Well, it's a relatively new project, so we have lots of work left to do. But these are our latest statistics from the Lighthouse Chrome extension that measures things like progressive web app and performance. And as you see, we're hitting a lot of marks. So we're really proud of the work we've done here and the team behind it. Obviously, performance here is a work in progress. When you see the reporting from Lighthouse, the big performance issue we have is actually image optimization, which we're using all of the images passed from Contenta itself. So I think that's kind of an open problem that Ed also talked to a little bit. And I think we're hoping to, in the sprints tomorrow, that will be one of the problems we'll probably be talking about and trying to find a more generalized solution to. So with all of that, let me switch out here and show you the site. So this is the Contenta Angular site that many of you already have up on your phone probably. And as you see, you can kind of navigate around. You'll see that as I change the filters, they're reflected up in the URL bar. And there's not a whole lot going on here. Obviously, this is a pretty simple site on the face of it, but it's really those guts that we're interested in talking about and showing off. So we'll click around. These are all the Contenta consumer applications are built around the same data models, the same recipes and things. But what we're really proud of here is what happens when I turn the internet off and then refresh the page. It all still works. You can still navigate around. Everything still works. And if you want to see in the network tab, it's all coming from these service workers. So you can see those are all being served by the service worker. So that's what an offline website looks like. What the images like. Oh, and one neat thing about the way that we do service workers, because we're making external API calls and also those images are actually coming from a remote server as well, there's a small bit of extra configuration we had to add to our config. So by default, as I said, with those few commands I showed earlier, all your basic static assets and JavaScript and CSS will all be cached by the service worker. But you can also add some extra little things like this. So this is what allows those external assets to also be cacheable by the service worker. So even though we're pulling things from other places, we're still able to cache those and serve those out. So what is next for Contenta Angular? Well, we have a long roadmap that's all publicly accessible on our GitHub. And we have a lot of new features that we're working on and we're really excited about. So just to touch on them briefly, server-side rendering. So Angular Universal, as Stephen mentioned, is baked into Angular. And now they have just recently added CLI support for Angular Universal as well. So you can actually serve a server-side rendered application from the CLI. So we're really excited about that. When we started this project, that wasn't available, and we had to choose, are we going to go with the CLI or with Universal? And just for the sake of keeping those barriers to entry low, we went with the CLI. Now we're going to have both, the best of both worlds, and be able to serve our application on the server as well. And as you see, we've got a bunch of more things here that we're going to go through, but I think I'm going to hand it over to Stephen here to talk a little bit more about the future of where this is all heading.
All right, the future. You guys scared or excited? Okay, about 20% scared, 80% excited. Awesome. So, as Matt said, we have a roadmap for Content to Angular. First one is universal, so server-side rendering. There's really kind of two ways of doing server-side rendering. There's two use cases for it. The first is for what we call an app shell, which is, hey, we want to push down to the user something that looks right as quickly as possible. But then you can also serve down kind of fully dynamic content and run the entire application in the back end. And so both of these things are possible. Both of these things, we have tooling that tries to make that easier. We're working on making that tooling even better every day. One of the reasons that we need universal, as we all kind of shift more and more towards the front end, is that not all web browsing is done by humans anymore. A lot of web browsing is actually done by computers. And so if you look at search engines, some of them don't run JavaScript. So Google, for example, runs JavaScript, but it runs a earlier version of JavaScript, something on the order of like Chrome 42 or something like that. Scrapers, like Facebook, Twitter, whenever you want to share a piece of content from a web page, they're going to scrape your HTML and try and pull out a thumbnail for you. There's things like AMP, or accelerated mobile pages. All of these use cases require you to have a fully rendered page. And while JavaScript is necessary to deliver really great client-side experiences, right? Like you click on it, it loads instantly, the application works entirely offline, but you need JavaScript to also render server-side. And so having both these things is very important. So you're considering both the users and the humans that are consuming your content. Another piece that we talked about is animations. So in one of the earlier versions of Angular, I think probably 3 or 4 months ago, we released a bunch of new animations APIs. So you can do things like stagger and routing changes, and you can kind of, we have a declarative syntax that allows you to do and define basically anything you want to happen from an animation standpoint. And this all uses the Web Animations API under the hood. It's really exciting, really powerful. It's not just a beauty thing. A lot of people think, oh, it's just for looks. But animations can be very important for users because it gives important contextual clues to what's going on within your application. And so a user might not know what one of your buttons does, but if you can show an animation that says, hey, this slides up from the bottom or this fades away, that says, hey, you've done something right, here's a little reward, and here's a bit of context about what's happening in your application. Another feature that most users want at this point, although I've heard, I was just on Reddit a week ago and people are like, I hate infinite scroll. What? Reddit will be Reddit. So we want to automatically fetch all the right data at the right time. My big fan of the philosophy that don't make your users decide what content they want, right? Just naturally give it to them when they try and access it. Another feature that we are talking about is Schema Generation. And so this is a really big one, and Ed already has it, so fork you on GitHub.
I found the bugs that you'll hit too. So
nice. We'll work together. I love it. So we have a new tool that we've been working on that we released about a month ago or something like that called Schematics. And what it is, it's a generic, I'll say scaffolding tool, but what it does, it runs arbitrary code in order to do transforms of JavaScript or TypeScript trees. So you give it nothing, and then we give you an Angular application. So that's like that ng new experience that you saw at the beginning for scaffolding in a new application. But you can also do things like, hey, create a new component. And not only does that create that component file, but it'll also update links and create links in other files to that application. And we're not using regular expressions, so we're much, much more confident that it's safe. But the cool thing about this is because we can do this with arbitrary code, we can actually make web-based calls in order to do the scaffolding. So you could say, generate me or update my schema for recipes, and then we can make a build time call to the recipes API, which then generates the local services and all those sorts of configuration files that give you the type information and all of that. And so this is kind of a very powerful thing that's possible in coding today, just no one has done it. So we're going to be doing that soon. The next feature here is, as I said, we really want to be using, especially the API shape, and then using scaffolds to update those. Another piece is authentication and editing. So again, awesome demo. Very, very jealous and very excited for what you're doing for the community here. We want to make authentication easy too, and we would love to offer a contextual editing experience that posts back to Drupal. We did have these slides before he gave the presentation. All right, and then lastly, I want to talk just a little bit more generally about the future of Drupal and Angular, because it's not just about kind of decoupled web. One of the things that we're working on is a use case that we call Angular Embedded. So this is all about embedding Angular into additional contexts or other applications, right? So you're used to, in kind of traditional Angular today, I have to build an entire application in Angular. I'm choosing Angular for my entire stack. And we want to make it possible to build either subsets of that component or subsets of that entire app, and then ship that and put that inside of another application. So the three main challenges that we're working on each of these to enable that. First, we want to make all our bundle sizes small enough that you'd want to do this, right? Because you don't want to be loading 3 meg of JavaScript or 15 meg, which is the worst app I've ever seen. Second, we want to eliminate any extra work to do bootstrapping. We talk to a lot of companies that are using Drupal and Angular today, and they end up kind of manually bootstrapping components when they want to based on the blocks that are being loaded onto the screen, and we want to kind of automate that for you. And then lastly, we want to kind of simplify the build and ship process. So today, as I said, we have a CLI that does deployment as an application, but we want to add to the CLI things like shipping as a library or shipping as this embedded piece that you can easily put into another application. So the idea here is that we're going to combine the portability that you kind of need and want to be a web developer in 2018 and beyond with the kind of orchestration superpowers that Angular is trying to offer. One of the cool ideas that happens with this, if anyone's using progressively decoupled blocks, is that this could really ease the migration between a progressively decoupled block application and a decoupled application, right? If I can write the same code in a couple blocks and then say at some point, now I want to rewrite this and I want to reuse all that same code, that's the use case we're trying to enable. Another thing that we have and we talk to a lot of Drupal developers about is when they use Angular at scale, they end up running into a few problems, right? Maybe I have 100 different components or 100 different blocks that each get built as separate applications. And so now I have a build time for each of those, and maybe for some reason I have to do them sequentially because of some DevOps process that I've got going. So we really want to give better guidance and tooling to scale those kind of large-scale application builds. Longer term, we've got a project called ABC that is designed to make this easier for developers. So ABC stands for Angular plus Bazel plus Closure. So within Google, we've actually been building JavaScript for a long, long time, right? Like all the way back to the days of Gmail. And so we've developed really good compilers for JavaScript as well as bundlers for JavaScript. But now we've also built this system that we call Bazel that allows you to, instead of thinking of a JavaScript application as a single compilation target, you can have subsets of that application. So for those of you who don't know, within Google, we have a mono repository. So all of Google's code, everything from Gmail to Google Web Search to self-driving cars, it's all in the same repository, right? We have one ginormous repository. And the way we manage that is a couple things. We have very good policies. So for example, we ship code every day. So everyone has to have tests. And the policy is that if I break your tests due to some change that I made, I have to fix you. But if I break you without breaking your tests, you have to fix yourself. So because of that, everyone has very good tests, right? And the other thing that we do is we built out this build system called Bazel, which we actually open source, that allows you to rebuild and intelligently cache the different pieces. So for example, when I'm building an Angular application within Google, when you need to do that build, we're ensuring that not only is your application built, but that Angular is being rebuilt, that Node is being rebuilt, that the Linux kernel is being rebuilt, that GCC is being rebuilt. Obviously, we don't have to recompile all of those all the time, but it's intelligent enough that if something does change, it can propagate it through the entire system very, very quickly. If anyone remembers the Heartbleed SSL bug, Google was able to patch this across every system that we have in about a week because we only had one version of OpenSSL across the entire company, right? So you patch it one place, and then you just redeploy everything. And so we really like our build tools within Google. They work for us, and we're trying to empower the rest of the world with these tools. You can use Bazel and you can use Closure today. It is not easy. We work with a lot of companies that have tried and succeeded, and then a couple that have tried and failed. So the Angular team is kind of taking it on as our personal mission to make all these things much simpler for developers that are just trying to get back to work. Lastly, we really want to focus more on kind of enabling more different types of blocks that you can build and giving more out-of-the-box code. So solving some of these problems automatically for you. Really trying to both kind of start with guidance and then over time build out that tooling so that instead of kind of walking on a dirt path or blazing a trail, you're going down a highway. I loved all of your metaphors. I love your talk. Thank you, friends. Lastly, Angular is here to help. So whenever you run into a problem that Angular is not solving, let me know and we'll try and fix it. Thank you so much.